Welcome to Interval Notation, Represent Domain and Range. In order to represent domain and range, you need to learn interval notation. You probably haven't been exposed to it before, so we're going to go over it today. You're also going to become familiar again with the graphical, algebraic, and set builder type notations, because you may be seeing those as well. Let's review domain. Remember that domain is the set of all possible x values. That's your independent variable. So when you have a function, you have a graph, you have an equation, you can look at that and you can determine what the set of all possible x values may be in that function. Same for range. The range is the set of all possible y values. That's your dependent variable. Let's look at some graphical representations. Here on the left, looks like we have a quadratic. It's opening down. If we think about our domain, notice down here on the bottom, and you'll learn this is interval notation. They're saying the domain goes from negative infinity to positive infinity. So in other words, this function will have an x value anywhere from negative infinity all the way out to the right, positive infinity, and a range of negative infinity to 0. Notice it goes to 0 because the function does not go higher than 0 for y. The highest y value this function will ever have will be 0. So the function drops down, 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 down forever on the y-axis, but only goes up to 0. We're going to learn about interval notation, and if you'll notice, some of these are brackets and some of these are parentheses. Look at our second example. In this example, it looks like we have a rational function. And here we have two legs. Remember that we have asymptotes where the function will go up against really, really close, like a limit, but never actually touch the asymptote. So with that in mind, we have an asymptote here at 2, where x equals 2. And it looks like we have an asymptote here at 0, where y equals 0. So in this case, our range, this is a different type of notation to represent domain and range. But our domain says that x does not equal 2. So it's implied then that x equals every other number other than 2. And remember, it can't equal 2 because we have an asymptote here. Our leg will get really, really close, 1.99999, but never get to 2. Our range is the same thing. Our range says y does not equal 0. So again, our function is coming up really, really high, and it will go forever, but when it drops down, it's getting really close to the y-axis where y equals 0, but it will never touch it. Same thing with the other leg. Our final example here is a logarithmic function. And here our range goes from negative infinity to positive infinity, which means that this leg will go up forever and down forever. So it will always have a y value. Our domain goes from 0 to positive infinity. So that means it'll become 0. Well, actually, in this case, it's not actually going to ever become 0, and that's the identification of the parentheses here versus the bracket. But it'll get really close to 0, but never actually reach 0. But it will go to positive infinity. So now that you've seen some of this graphically, let's go ahead and start working on what this looks like and how we write these. There are 4 methods to represent domain and range. The first one is graphically. So in this case, if you remember, a closed circle means the number is included in that domain. So in this example, -6 is included. And then we include all the numbers in between -6 and 4. But because this is an open circle, we don't actually include 4. So we go all the way up almost to 4, but we never actually reach 4. So how would we write this algebraically? Well, algebraically, we use greater than, less than, greater than or equal to, or less than equal to, or maybe does not equal. So think for a minute, pause the video, and see if you can write this same domain, but write it algebraically. And here we go. Using our inequalities, we say that x here in the middle is less than 4, notice it doesn't say less than or equal to. It just says less than because we don't include the 4. And then if we read to the left, we are saying that x is greater than or equal to -6. And that's because we actually have a colored in -6. Remember that when we color in a -6, that means we are actually including that. So greater than or equal to. Let's now go to interval notation. This is going to be very important because we're going to be using this quite a bit as we move forward in this course. So it's important that you understand how to write domain and range using interval notation. Well, what we say is that if we use a parentheses, we are not including the number. If we use a bracket, we are including the number. So let's look at what this is. We are going to have a bracket here by the -6 because we are including -6. Remember, it's colored in and we have a greater than or equal to here. We don't use x and y's when we're using interval notation. We just use the numbers. So we do a comma to represent through, just like this line here. So we know we're going to go from -6, including that, all the way to 4. However, we are not going to include the 4, therefore we use a parenthesis to indicate that we go all the way up to almost to 4, but we don't include the number 4. And that is how you show an interval, a range between -6 and 4. Finally, we have set builder. It's not as common, but every once in a while you see it. And this is really the format up here. We draw a set notation, and then we use a variable. It doesn't really matter what variable. We say that x, the set of x, and this is where the x is, just a placeholder, such that, and then we really just repeat our algebraic, such that, in this case, x is greater than or equal to, let's make that a little nicer, greater than or equal to 6, and it is less than 4. And then we close the set. Let's go ahead now and summarize what we just said. So a closed circle, a less than or equal to, a greater than or equal to, and a bracket, any of those means that we include the number. If we have an open circle, a less than, a greater than, or a parentheses, any of these mean it does not include the number. So how are we going to use this? Well, in your practice on the next page, you're going to get a worksheet like this one. And what you'll have to do is fill in the blanks in order to complete the table. So you'll be given one type of notation and you need to write the other 3. Notice on the first one we have x is greater than or equal to 6. So we would write that as set builder notation, graphically, and an interval notation. Let's review a couple things in order to help you. This sign here, that's the infinity sign. This R, this cursive R, means all real numbers. So all numbers, basically. This cursive looking E here means it's an element of the set of. So if I look at this bottom set builder notation, we have the set of x such that x is in the set of all real numbers. Now as you go through this, you may see some things that you're not sure how to deal with. Like what about this one? X is less than 2 or x is greater than or equal to 5. Well, when you're doing interval notation, one interval is not going to work because it doesn't include the numbers between. So in this case, you'll have to take each of these separately and you will have 2 intervals. So you'll have one where x is less than 2, meaning -infinity to 2, and then you'll have another one where x is greater than or equal to 5. So you'll have 5 all the way to infinity. Now one thing that I failed to point out earlier was that anytime you use the infinity symbol, it's just a symbol meaning you're going in a certain direction. We always use a parentheses when we're dealing with infinity. So if I was going to write something from -infinity to positive infinity, I would use a parenthesis, -infinity, positive infinity, and parentheses, never a bracket. And if we go back to our very first page and we look at how they have written this, you'll notice that our domain was parenthesis, parenthesis, and our range, if we'll go back to that, was parenthesis around the negative infinity, but bracket around the 0, meaning right here, we included the 0. It was part of our range. And that concludes our lesson today on interval notation. So hopefully you will practice this and become very familiar with it so that you can use it as we explore families of functions.